Alright, let's go ahead and continue our kinematics. So far, we have covered distance and displacement, and we're going to move on to speed and velocity. We've also covered the terms of scalar and vector. So just a reminder, a scalar is any quantity that has magnitude only or a value only. A vector is a quantity that has both magnitude and direction. So meaning it's going to have some value plus a direction. And so at some point what I would like you to do is to fill in these two columns of distance and displacement, giving the equation for distance, and really there's no equation for distance, it's just total path traveled, and then the equation for displacement. There are no, so when you get down to these two columns right here when you're doing distance and displacement, is to just cross out these 2 points, right? There is no triangle method for distance and displacement. And I would like to cover the units for distance and displacement before we jump into speed and velocity. So we know that there are SI units, and we've covered those, but just to kind of review, what is our SI unit for distance and displacement? Well, it is meters. Right? There's no prefix, right? So it's just the base unit. Right? But other units that you might see are kilometers, centimeters, millimeters. You might see miles, you might see feet, yards, right? Anything that's going to tell you how the length of something. Right? And if we're given kilometers, miles, feet, yards, any of those, right, we need to know how to convert those. So that's why we've been practicing dimensional analysis. Right? And for displacement, the only thing that's different is it's going to be all the same. SI units, meters, you can see kilometers, centimeters, miles, feet. The only thing we need to add is it would be meters and then some kind of direction. So it could be north, east, south, west. It could be up, down, left, right. Right, basically any value plus a direction. Let's go ahead and go up to speed. So with the web quest that you did, you looked up the definitions of speed and velocity, which is speed is the rate at which an object moves. And speed, is it a scalar or a vector? Well, speed is a scalar, meaning it is only going to have a magnitude. It does not care about direction. So speed, once again, does not care about direction. What is the equation for speed? Speed is v. Right, v is going to be our symbol for speed, equals x, which is our symbol for distance, all over t. And t is for time. So just once again, I'll write that down. V stands for speed. X is for distance. And then T stands for time. I'll come back to the triangle method in just a few seconds. Let's go ahead and look at our SI units for speed. Our SI unit for speed, or the unit that all scientists will use, is meters per second. Now, we might also see kilometers per hour, so we'll need to be able to convert kilometers per hour to meters per second. We might also see miles per hour, feet per second, basically any distance over any time unit. Right, and we'll have to always be able to convert back to meters per second. All right, so now let's go ahead and go to the triangle method. You might have seen this before, but really it's just a method to rearrange the equation without having to do algebra. So let's go ahead and make our triangle. To look like this. So in the top point of our triangle, we need to put x. X for distance. V in the bottom left, T in the bottom right. Alright, so how is this useful? So let's say that in a problem, we are given how fast something is going and the time that it took. And the question's asking, okay, how far did they go? Well, how do we use the triangle? Well, cover up what you don't know. So in this case, we didn't know how far they went, so I covered up x. And now the v and the t are in the same level, so that means we need to multiply them. So in the problem, we would multiply whatever the speed was times the time, and that would give us the distance. In another case, we might be given speed and distance, how far they went, and figure out how much time did it take. So we cover up time, and we divide x by v, and that would give us how much time it took. So let's go ahead and do a practice problem. So it says a jogger runs 12 laps on a 400-meter track in 14 minutes. What was her speed in meters per second? Right, so we were told that 12 laps on 400 meters, so that's probably going to tell me x. So x is equal to 12, and since we went 12 times on a 400-meter track, we'll go ahead and multiply 12 times 400. All right, well, 12 times 4 is 48. Add 2 zeros, we got 4,800 meters. And we're also given time it took, so time is 14 minutes. And we notice that in the problem, we're asked for meters per second. So meters are minutes, we need to convert our minutes to seconds. So minutes going to be on the bottom because we want to get rid of them. We know that there's 60 seconds in 1 minute, so we're going to cancel out our minutes. So we're left with 14 times 60, which is equal to 840 seconds. So equal to 840 seconds. Now, let's go ahead and practice our triangle method. So I know x and I know t, so I'm looking for v. So I cover up what I'm looking for, and that tells me to divide my x by my t. So now I'm going to go ahead and go down here and say that v is equal to x divided by t. So now I'm just going to substitute and solve. So 4,800 divided by 840 is equal to 5.7 meters per second. So 5.7 meters per second. And we're done with speed. Now let's go ahead and go up to velocity. Velocity is the same as speed, except it has direction. So that makes that a vector. So it's going to have some value, a magnitude, with direction. And really the equation doesn't change. We just change our symbols to show that we're dealing with velocity and not speed. So with velocity, what we try to do is use a V with an arrow on top. So that arrow means that we're dealing with velocity, meaning it has a direction. Like usually an arrow points in the direction of something that's going. Velocity is equal to displacement. So our symbol for displacement is delta x. So delta meaning change in x. So our displacement over time. All right, so once again, our v that's going to tell us velocity. Right, and sometimes you'll see the v without the arrow, but direction is included. So you just need to know that you're talking about velocity here. And then once again, delta x tells us displacement. Displacement is also a vector, so displacement has direction. And then t is still time. The triangle method does not change in this case. All right, once again, the only thing that changes is what symbols we're using. So you'll have delta x on top, you'll have velocity and time. And the only difference between speed and velocity, once again, is that it has direction. So still meters per second, but then we're going to need a direction. So it could be up, down, left, right, it could be north, right? It could be meters per second east, so on and so forth. Let's go ahead and check out one of these problems. So car travels 150 kilometers east for 1.5 hours. What is the car's velocity? So I'm looking, I see displacement is 150 kilometers east. All right, so we're given a magnitude of 150 and a direction of east. And we're told that it took 1.5 hours to complete this trip. What is the car's velocity? And really we're looking for average velocity. And the problem doesn't ask for meters per second. So in this case, this problem asks for meters per second, but this one doesn't. So when it does that, we do not need to convert. So our velocity is equal to, if we use the triangle method, right, we don't know v, so x over t. So we're going to divide x by t, or displacement, change in x. So therefore we have 150 divided by 1.5. 150 divided by 1.5 is equal to 100. So we divided kilometers by hours, so our new unit is kilometers per hour. And what direction did we travel? East. So our final answer is 100 kilometers per hour east.